Recording in progress.
Hello，长水。Hello.
Hello, good afternoon, everyone.
Right.
Hello, good to see you here.
Yes, I can see you, Dr. Xie.
Hello, Professor Xia.
Good afternoon.
Good afternoon.
Hello, Professor Xiang. Can you hear me?
Yes, Dr. Chen, very clear.
Okay, thank you.
Hey, 乔老师你好。哎，乔老师你好。
OK，好了。 Hello, Farzil. Farzil, are you here?
Yes.
Oh, great. Thank you so much. Fred. Fred, are you here?
Yes, Professor Fang Li, I'm here.
Okay, thank you so much. And the Botal? Oh, Botal already here. Yeah, I noticed. Thank you so much. We will start a few minutes later. We still have maybe 1-2 minutes. So
2 minutes. Good to
2
see you
minutes,
here.
Yeah. We will keep time.
Professor Chao.
Oh, Azam.
Hi.
Azam. Hi.
Hi, Professor Chow. How are you?
Nice to meet you. Yeah, very good.
Yeah.
Good afternoon, Professor Chow.
Hi, good afternoon.
There are so many new faces. I don't know yet. So sometime I would like to meet you in person somewhere.
It's good. If we don't know some people, it's very good. That means we are old.
Good afternoon, Mr. Zhou. This is admin for this session. Okay, just a few quick questions. This session will be 2 hours, and I will be putting the timer up on the screen later on. Would you like me to set the timer per part, which is divided to 4 parts, or would you like to set me timer straight 2 hours?
I think maybe 2 hours, not exactly 2 hours, maybe a little more. It depends. You know, we will try to keep time. Okay.
That's all right. It's just the guideline for you. It won't be cutting the video, even if it's exceed 2 hours. It's still keep on going.
No problem. Okay, it's okay.
Okay, so I set it at 2 hours.
So cut the video, no problem. Yeah, sure.
Okay, and another thing is that we would like to have a group photo before the session starts.
Good. So I hope everyone can open the camera, and the administrator would like to take a photo for us. So yeah, open the camera.
Just a moment, we are waiting for some more people to turn on the camera.
Sure. So please open the camera. So, and the administrator would like to take a group photo for us. Oh, somebody here.
Hi, Professor Fang Li.
Hi, good afternoon.
Good afternoon. How are you?
Very good. Thank you so much.
Hello,
did you what? Hi, but I didn't see you for a long year.
Yeah, for 10 years.
Yeah,
more than 10 years.
Healthy. You look healthy.
So please open the camera and we will take a group photo. Open the camera, please.
So did you watch the openings?
So they would like to take a photo. Yeah.
Song Kiat.
Yeah.
You was exactly the same like 10 years ago. What happened?
Even younger. Even younger.
Getting old now.
So, is it okay?
Can we have people look at the camera, please?
So please open the camera. Yeah. Please open the camera. And yeah.
Okay, 1, 2, the first one. Hang on, it's a few pages, so I need to wait for it to download.
Yeah. It's okay. The first page is full.
The first page is okay. The second one, you hardly have anybody on.
Please open the camera, and we will take a group photo. Thank you so much. So, is that okay? So maybe.
Yeah. Somebody messaged that they're not having camera on the computer. So, but I mean, it will be the name on the. But if anybody has camera on, could you please turn it on so that they can take photo, please?
So please open the camera and yeah, show your face. Open the camera. And more. Yeah, please open the camera.
Okay. Thank you very much, sir.
Okay, I think if it's okay, we will start our meeting. It's okay?
Yeah, sure.
Okay. So on behalf of all our organizers, so this meeting is co-organized by Professor Frederick Tangang, UKM of Malaysia, and Professor Bo Taoxie, China National Offshore Oil Corporation, China. And for me, it's I'm Fang Liqiao from the First Institute of Photography, Ministry of Natural Resources of China. It's our great pleasure to organize this Incubator 7. It's a seamless ocean forecast and service system for predicted ocean, from ocean to climate. As we know, observation and prediction is two main tools to support management, to support the government. And as we know, the prediction is still have a lot of ground challenges. We hope through this incubator we can have found more partners to cooperate in this area, and we can we have a program proposal to UN Ocean Decade. So this is our main idea. For this incubator, we have 4 parts, and the first 3 parts is for science. The science first is why the need for and the challenge of forecast and service. So we will have 3 invited speakers. Each one have 10 minutes. The second is how. It means the transformative SOS science and technology. It means how to face the challenge to provide high quality prediction service for the government. And the third part, we have 2 speakers. They are focused on the applications of the ocean forecast system and climate systems. And the last part, we will have 20 minutes for discussion. And after each session, each one, we have 10 minutes for presentation. And after that, for each part, we will have 5 minutes for discussion. So this is the whole structure of the incubator. So welcome all of you. Now I would like to transfer to the Dr. Fadzel. He will chair the part 1. So Fadzel, please.
Okay, thank you very much, Professor Fang Li. Thank you very much, everybody. I think we have about 62 participants this afternoon, which is very interesting. We will have 3 speakers in this session. So I will introduce you to our speaker. We'll be having Dr. I'm so sorry. So Dr. Liu Juning, Professor Bo Taoxie, and also Dr. Azam Chaudhary. First of all, I would like to introduce Dr. Liu Juning, who is my dear friend in Malaysia. So he's an associate professor in the university in the Department of Earth Science and Environment, National University of Malaysia. So his research is interest is encompass various aspects of regional climate dynamics over Southeast Asia region, with specific focus on interannual and long-term climate change timescales. So in addition, he also interested in the issue on regional air quality and also which in association with regional meteorology. So today he's going to present a topic on the regional climate prediction and projection and oceans component roles in it. So, Dr. Juning, so the screen is yours.
All right. Can everyone see the slides that I just shared?
Yes, we can see it.
All right. Great.
Yes.
So, good afternoon, friends, colleagues. My name is Liu Juneng, and I'm from the Department of Earth Sciences and Environment, University Kebangsaan Malaysia, or that's Bahasa. So if you like it in English, that is the National University of Malaysia. So over the past few years, I've been working together with Professor Frederick Tangang and also many colleagues from the Southeast Asia regions as well as outside the regions. We work on a climate projection downscaling under this Codex Southeast Asia project. So which is basically a program coordinated by the WCRP. So basically here we are interested in long-term changes of the climate in the regions. It is my pleasure to have the opportunity here today to share some of my experience with respect to this. All right. So as we know, assessing the risk and impact of climate change involves a cascade of modeling layers, starting from the projections of pathways of the radiative forcings, and then simulating the responses of global climate to these radiative forcings through the use of GCMs, and then later on downscale the output to regional or local scales, and use that as an input to some form of impact models. So among these steps, the downscaling basically plays a very crucial role to add in local informations. On top of that, that has been simulated by the GCM. So there are basically many ways to conduct this. So we have the dynamical downscaling, we have the statistical downscalings. But the dynamical downscalings here specifically involves the use of regional climate models, or we call it RCMs, so which check the GCM's output as a boundary condition. So this downscaling approach is especially computationally expensive due to the requirements to consider basically multiple GCM as well as multiple different possible radiative forcings in the futures. So so in the Codex project that we have been participating, for the past 5 to 6 years, so we put together resources, basically expertise and computers from around the Southeast Asia region, so to conduct this dynamical downscalings. And also several RCMs. So this will better allow us to sample the uncertainties associated with different sources in the futures climate projections workflow. So basically the map here, if you can see the map, so this is sorry. So if you can see the map there, basically that are the regions that we consider, and all the simulation were conducted using this domain with 25 kilometer grid resolutions. So the project members come from over 20 institutions from 14 different countries inside and also outside of Southeast Asia. So if you want to know more about the project, so those that are the websites, and also we also archive the data and distribute the data through assistant grid federations to the public. So if you're interested, you can go ahead visiting our website. So basically, there are many regional, as mentioned, there are many regional and international institutions involved in the projects. And the table here basically shows the list of GCMs and also the regional climate models, the RCM that was used in providing the projection downscale informations for the regions. And also you can see the scenarios there. So there has been a lot of computational resources put in to come up with the data. So over the years, the total simulation year is about 4,000. So anyway, the point here is that if you look at the RCMs used, they have one common characteristic. So all of them basically are atmosphere only models. So that couples to only the land surface processes, but you there is no ocean component in it. So the lower boundary conditions is prescribed from the surface temperatures coming basically from the GCMs. Therefore, the simulation does not consider the regional AC interactions. So is there any problem with that? Frankly, at this point, we don't really know. So I believe using the atmospheric only RCM is a common approach adopted by many, many international centers, and many people do that. So, and this is probably due to, if you want to consider the oceans, there probably a lot more computational resources is required. So anyway, what is shown here is basically the comparisons of rainfall annual cycles between the observations and basically the ensemble members of the RCM simulations. Here we divide the regions into 20 basically subregions, and then we consider the area means in all of our analysis. So the black line here is basically the observations, and the blue lines are the ensemble of the simulations. As you can see, in the RCM simulation, basically you can see consistent wet bias over most of the regions, right? And then the next figures here basically shows the same information, but this is for the temperature. So over the same 20 subregions, as you can see, the colorful line is basically the simulations, and the black solid and dotted lines are the observations. So as you can see, there are consistent core bias as well. So from these results, we know that the Codex Southeast Asia simulations are generally too wet and also too cold in the model. So assuming, basically, we assume that the biases is stationary across the time, and then we then go ahead, estimating the projected changes in the regional climate and futures. Yeah, there are some samples of projected change in the rainfall of Southeast Asia from the simulations. Taking, for example, here, basically this is a change of seasonal rainfalls during the DJF and JJA for the two different representative concentration pathways considered. And basically the projections estimated, during the winter, the rainfall over the mainland Indochina is expected to increase. But during the summer times, the maritime continent is expected to, the rainfall is expected to reduce. So similarly with the drought condition represented here, just taken for example, we use the consecutive dry days index, which is projected to, expected to be worsened in the future. So consistent with the drying climate signals. So, however, as mentioned, the model is biased, and then we don't know how or if the biases actually affected the climate change signals that we see in the future. So there's no explicit information on how the biases actually affected the climate predictions. There are some people applied some kind of bias corrections, post-processing routines to correct the biases before interpreting the data, but this does not actually free the approach from bias stationary assumptions. So we still assume that the biases is somehow time stationarity. So to me, I think this is will be the crucial source of uncertainties in the projections. And up to this point of time, I believe a majority of the downscale climate projections data users are not only over the Southeast Asia, but around the world, I think. So do not take this into account in their risk assessment or workflow. All right. So now what has this to do with the oceans, or specifically the AC interactions that we are talking here? Basically, what the map here shows the result of the simulations using the same models, but driven by this error interim. So this is basically essentially our validation run. So you see the different numbers here. Basically, the same model runs, but we use a different parameterization schemes, different cumulative scheme, different PDLs in the models. So the results here essentially the point-to-point temporal correlations, which is a year-to-year of the yearly time series between the simulations, between the regional climate model simulation and also the parent model. So in this case, this is the error interims. Regardless of the parameterization used, we see a very similar patterns here. So therefore, this result basically tell us, the rainfall processes. If you see those areas in the mainland Indochina, you see the negative correlations. So what does it tell us here is that the in the RCMs, Codex RCMs basically, so the feedback is basically wrong, or essentially the feedback is exactly the opposite of those you see in the error interims. So if you take the area interim as observations. All right, so what is going on here? What the pictures here basically shows you the correlations between the rainfall and some climatic fields. The rainfall, which is mentioned, is basically the area average rainfall over the black box. So if you can see the black box there. So those are the areas where we construct the rainfall time series. And then the field considered basically the sea surface temperatures, the 850 hectopascal winds, and then also include the surface fluxes, the latent heat flux and the sensible fluxes. So, and this is, by the way, this is computed for the summer. So the bottom two rows are the result computed from observations, and the one used the area interims as a representation for observation. The other one basically used a true rainfall. We do that for cross-checking. So the first row is a result from one of the RCM simulation that we choose. So here we can see, there's a very inconsistency. There's a large inconsistency between the simulations and also the observations, in which the simulation shows positive correlations. And then the simulation basically shows the positive correlations. If you look at the South China Sea area and the Andaman Sea, you see red spots. But that in the observation is actually totally opposite of that. So, and a part of the surface temperatures, what you can see is that the correlation between the rainfall and also the other, the latent heat flux and the sensible heat flux in the RCM simulation, it is also appeared to be opposite of those observations. So therefore, I think there is a clear indicator that the surface atmospheric feedback process is in the RCM simulation is totally opposite of that what we observed. So we conjecture or we hypothesize that there's a lacking of AC interaction in this case, which basically resulted in missing or weakened negative feedbacks due to surface cooling by the rainfalls, and therefore it results in the forced atmospheres being too wet and also being too cold in this case. So in fact, there is also a couple of, there has already been a couple of numerical studies by some Chinese scientists that supported these conjectures. So they have through numerical experiments. So we know, especially during the summertime, the AC interaction is particularly crucial. In getting the signals, at least the atmospheric, at least the rainfall process is correct in this case. So we know at this point the Cortex size simulations output is generally too wet and cold, but still we still use that to estimate the futures, but we are not sure exactly at this point of time how this actually affects the projected future climate. And here we hypothesize that this is probably due to a lacking of AC interactions. So Cortex South Asia projects has currently progressed into the phase 2. And then in the phase 2, we focus a lot on answering the questions of how does the model simulations basically affected the bias. Yes, so we do see when we increase the resolutions to 5 to 2 kilometers, basically we see reductions in the bias, particularly the biases in the rainfalls. But however, I think if you consider regional wise, the AC interaction is still very important, and I suppose the effects of the AC interaction is equally likely important if you compare that to the resolution. So probably in the futures we need to really consider that in our future works. Yeah, I think that's basically all of my presentations.
Thank you very much, Dr. Jineng. Thanks a lot for presenting within the time frame. Right, I would like to invite our next speaker. Don't worry, if you have any question, we will have some discussion at the end of this session. So you'll have time to ask our speaker. So our next presenter will be Dr. Zhe Botao, which is the Chief Engineer of the Environmental Condition of China National Offshore Oil Corporation Research Institute, China. So his research focuses on design criteria of ocean environmental condition. So he's going to present to us on the topic of the requirement and application of oil and gas development for ocean forecast system. So over to you, Dr. Jay.
波涛，你的声音没打开，声音，打开声音。
Oh, thank you, Chairman. Ladies and gentlemen, good afternoon. My name is Xie Tao, and I'm from China National Offshore Oil Corporation Research Institute. It's a great pleasure to end this kick-off meeting. And the title of this presentation is the requirement of and the application of oil and gas development for ocean forecast system. The purpose of this presentation is to introduce the requirement from the industry field. So I'd like to divide my talk into 4 parts. First is the background. The background is the special mid-ocean conditions in the China Sea. And as we can see in this picture, the environment conditions of South China Seas are very complicated. The extreme environmental loading induced by the typhoon and the internal waves gives great challenge to offshore platform structures. And comparing the characteristic of environment conditions of the major oil and gas regions in the world, the typhoon, storm, swell, and the internal waves should be considered in China Sea. So we should be very focused on the ocean environment. Next is the mid-ocean data are the basic data, which has important significance to the energy design, investment, and safety in the offshore and gas development. For the reason of risk reductions, cost reduction, and duration reductions, accurate estimate of the ocean forecasting are important for the installations, operations, and for the project. The second part is the requirement for ocean forecast system. In recent years, the floating platform are usually adopted in the deep water area in the South China Sea. The predictions of ocean waves and current are necessary for the constructors, design, and installations at the sea. For example, for the floating platform, we focus on the wave spectral, the current profile, and the internal frequency. So, in the floating platform design, the process of ocean dynamic environment conditions are important to the construction design, especially the typhoon. We very focused on the development of the wave spectral development during the extreme conditions. And the offshore installation operations are very sensitive to the swell, which having long-term wave period. Offshore construction of operation usually divide into the shipping operation, transportation operations, and offshore installation operations. So it will seriously affect the operation capacity and the safety of the whole project. The third part is the application of ocean forecast system. In these sections, I will take a real project just finished this year. As we can see in the picture, it's called the Deep Sea #1 Energy Station at Lingshui gas field in the Hainan province. This station is China's first deep water self-operated gas field station, and with an average operation water depth of 1,500 meters. This platform was assembled at Bohai Sea, and it was delivered on January 14th this year, and eventually reached to the Hainan on February 6th. Long-distance touring of deep water oil gas production equipment is the first time in China. So the ocean forecast system provides significant operational guideline for the whole trip. In recent years, we are developing digital technology that built on what is unique to us, like this, the digital twins of the platform. And we built a real-time digital representation of the map oceans. As we can see in this picture, the real-time digital representation of the map ocean by the ocean forecast system. It can updated by the observing data real-time, and it can analyze the platform attitude and take promote management for the platform according to the prediction of the oceans. The final part is the conclusions. As we can see, the UN Decade of Ocean Science describe a great picture of the oceans. Some challenges are very important for the industry field. So we were very interested in the future research, and okay, that's all. Thank you.
Thank you very much, Dr. G. All right, let's move to our next speaker, which is Associate Professor Dr. Azam Chaudhary, who is currently employed as an Associate Professor at the Department of Oceanography, University of Dhaka, Bangladesh. So he's formerly a Navy Lieutenant Commander. So he holds a PhD in Physical Oceanography and Ocean Modeling from the Ocean University of China. His research focuses on the Bay of Bengal and the Equatorial Indian Ocean. He is particularly interested in coastal research, climate change and sea level, which includes tropical cyclones, ocean forecasting system, temperature inversion, physical biochemical interaction, and blue economy. So, he's going to present on the ocean forecasting system for blue economic growth in Bangladesh. So over to you, Dr. Azam.
Can you hear me?
Yes, yes, perfect.
Thank you, Professor Fadli, for giving the opportunity to talk. Thanks a lot to the convener of of the Decade Action Incubator 7. Professor Fang Chiao, Professor Thangang, and Professor Xie, they are the convener. And dear audience, please take my warm gratitude from the Dhaka. This is the capital of Bangladesh. So myself, Azam, I'm a Western professor of the University of Dhaka. So today I'll talk shortly about the importance of ocean forecasting system for Bangladesh. So my title is Ocean Forecasting System for Blue Economic Growth in Bangladesh. So you all know that if a country like Bangladesh having a small like the coastal area and have the ocean, so if we have ocean monitoring and the ocean forecasting system, that will obviously upgrade the lifestyle of the coastal people. So ocean forecasting system generally provide some basic parameters like the temperature, salinity, the current, wave, sea level, and some biogeochemical parameters. And we also have seen some case study, like some in some occasions we can use the ocean forecasting system to get some benefits. So if you see the coastal area of Bangladesh, you can understand what is the situation. Like this is a low-lying area, and population are so dense here, but we are affecting with the sea level rise. We have the salinity intrusion, and floods, cyclone, storm surge is very common in every year. And this area is like the coastal erosion, accretion is the very common because of the delta progradation is there. Even though we have some opportunities, like we have the port, shipping, and the resources, salt industries, minerals, and the marine tourism sector is here. And we have the Navy, we have ship, submarine. So there are like some ship accidents, oil spill. These are common here. So for Bangladesh, actually, if we want to achieve the SDG, that is Sustainable Development Goal, and if we achieve the blue economy, for this type of sector, we can utilize the ocean forecasting system. So these are some pictorial view, like the natural disaster here, the oil spill. It's very common here, and we have used fisheries. There is a coral island, have a coral bleaching, and we have the shipping accident, and we have the tourism sectors. So if we utilize the ocean forecasting system, we can help our country with that. And you know that last 10 years, like it's about 10 years, we achieved the boundary delimitation between the India and Myanmar, and we have this sea area now. So, so it's the proper time to utilize our ocean. But what we have actually, we have some like flood forecasting system. They use the MIC model, flood forecasting and warning center. And there is a model like WRF model they use for the weather forecasting, but we don't have any operational forecast system here. And we also have so many lackings, like our physical oceanography is very lacking, like we don't have that much of high performance computers. Research vessel is not there. We just use some small vessel, hydrographic vessel and fisheries vessel to explore the ocean. Of some mooring buoy, and for the modeling, actually we need dedicatedly river discharge station at the mouth of the river. Still we don't have, and we need to rely on some satellite and reanalysis and model data for our study. So actually, if we utilize, we collect the data, we can management manage it, and we use for the ocean modeling, and we can serve it to the nation and to the coastal community. So ocean forecast system is trying it here. With that, actually, we are trying to establish one research ocean forecasting model. And for that, Professor Fang Li Chiao is the mentor. He is helping us. And now this is our model domain for our study. And these are some result, like we use the input of river. You see that there is one big river and have a huge river discharge. Yeah, we use this river input to the model, and our model is have the resolution 1/30 and 50 layers is there. For initially, we actually try to compare with the result of the FICOM and the HICOM, and we see which one is better for our result for the initial condition and boundary condition. I'm not showing the result here because of short time constraint there. And for the tide, we use the TPXO forcing, and for the atmospheric also, we used data sets from the ECM, WF, and GFS, and we try to compare which one is better for this region. And for the mixing, we use the Miller-Yamamoto scheme, and now we are trying to couple the SWAN model, web model, to provide the web mixing to the model, and still we are on the process with that. And we see the tide, we compare tide with the tide station, a few stations with the model, and the result shows like something maybe not bad. And we just compare some validation here, like SST and sea surface salinity. So it's like comparable, and we compare with the surface salinity of the satellite and the model. We see the comparison. Root mean square is like about 0.3 or 0.4, something like this. And this is some vertical profile of temperature for different season. And the root mean square is about 0.3 to 0.4 or 5, something like this. This is the salinity. Obviously, the salinity, there is a problem in the surface. Like surface salinity in the model is little higher, even though the root mean scale is like about 0.2 or something like this. And so I'm not showing all the results because of the time constraint. And so we are actually trying to set up a model, and this model can be a groundwork for future operational ocean forecasting system to set up the ocean forecast system in Bangladesh. So we need the international collaboration. We also need the help from our government for this, because we have so many, we have lackings of so many things, like we need observations, we need data, and we also need some training, and obviously the funding. And you are welcome for some joint research, which will help us actually, because we are very new in this field. And this is from my side. Thank you so much.
Thank you very much, Dr. Azam. I just would like to ask Fang Li, should we have a discussion because we are slightly behind schedule?
Yes, we have 5 minutes, so you can have a 5-minute discussion.
All right, so let's have a 5-minute discussion. So I would like to open to the floor to all participants. If you have any question to our 3 speakers, so you can ask the question. Do you have any participant wanted to ask any question? Or if you have any question to put it into the chat box, I will read it for you. Or I can I have one? I asked one question to Juneng. Juneng, are you still there?
Yeah, I'm here.
Yeah, I just wonder how important is Codex? What kind of contribution can Codex provide to ocean research, especially in terms of modeling and understanding the impact of climate towards the ocean, which I understand that it is basically an atmospheric downscaling, but how it can benefit the ocean research in general.
I think with that respect, for instances, I've been working with local one of the a company that who works on the port. So what they want is they want to estimate that they want to assess basically the impact of the climate change to how does that actually affect their port facilities and also their port management in the futures. So they basically request informations like winds and those things, and then they run the model. So to me, I think if you didn't get the AC interactions correct, so the informations might not be that crucial. So remember that data like winds, variables like winds, like pressures, those are the input to the oceans model if you like that. So I'm hopefully by through improve our understanding on how does the oceans and atmosphere actually interact over this region. So providing a better projections for the futures. Yeah.
All right. Thank you very much, Juneng. Can I have maybe one question before we move to the next session?
Okay, I have a question.
Yes, please.
Can you hear me?
Yes,
okay.
yes.
Go on.
I have a question to Dr. Azam. Azam, are you here? Are you online?
Yeah, I am here. Please.
Okay, I have a question because the river discharge in the Bay of Bengal is very important. I want to know which government department in charge of the river discharge observation in Bangladesh.
Yeah, thank you so much. There is one organization is called Bangladesh Water Development Board, that is BWDB. They are the authority to collect the river discharge. Okay. Bangladesh Water Development Board. Yeah.
All right. Thank you very much. Thank you all for joining the first session. So I would like to thank everybody for joining. So please join us for the next one. I will hand this over to the next convener, Professor Fredolin Tanggang. Prophet, are you there?
Yeah. Thank you, Prof. Fadil. And thank you to Prof. Fang Li for inviting me to co-convene this session. It's quite important for us in the region to have deal with this ocean forecasting system. Now it's good that connect with the climate, because climate is dependent on the ocean basically. So most of you perhaps don't really know me much. I used to be active in the ocean forecasting system. Some 10 years ago, I initiated ocean forecasting project with Professor Fang Li. But I was so busy with IPCC and also got myself into regional climate, downscaling, and been working on that since then. But as you know, as indicated by my colleague there, climate projection is dependent on the AC interaction. So advancement of science on the ocean forecasting, on the how interaction between ocean and climate is very important. So this session perhaps deal with that, the transformative SOS, science and technology. Although very short, only like 30 minutes and only 3 talks here. I think we have important issue here to discuss, and with us today we have three renowned speakers. So let me first invite Professor Fang Chao, my friend. Prof. Chao is the APG member of the UN Decade of Ocean Science for Sustainable Development, co-chair of the UNESCO IOC-WESTPAC, and Deputy Director General of First Institute of Oceanography from the Ministry of Natural Resources, China. So without further ado, let me give the floor to Professor Fang Chao. 10 minutes, Professor Fang Li.
Okay, thank you. Thank you, Fred. So it's my great pleasure to share some scientific breakthroughs on model development from ocean to climate. So my presentation includes 4 parts. The first is requirement and challenge. As we know, so today we discuss about the UN Ocean Decade. For the UN Ocean Decade, there are 7 outcomes, and a predicted ocean is one of them. So today, my talk will focus on predicted ocean. As we know, a predicted ocean is not only ocean itself, but also including climate. However, we face very serious challenge from ocean to climate. Here I show the mixed layer. The mixed layer, as we know, is play a key role in climate change, in typhoon evolution, and in marine ecosystem.
Professor Fang Li, I'm sorry, your slide doesn't seem to be moving on my screen. Is it people
really?
See similar things?
Yes, similar. I was about to ask about that.
Really?
Yeah, we can't see it move. Yeah.
Really? What was wrong? I try again. Try again. Sorry for that. Why not? Let me try again. Oh, I forgot. Doesn't matter. I will try to finish as soon as possible. Don't worry about that. I will. Let me check where it is. Oh. Why I could not find the file. Oh, so sorry. Why? Close. And again. Now does it work?
Yeah, we can see your screen, but not the presentation.
So this one.
Yeah. Okay. Can you?
Yeah. This one.
Yeah. Can you make it in the presentation mode?
Yeah. This is a presentation mode
good.
already.
All right. Proceed.
Okay. I will as soon as possible. So my talk was I discussed about the challenge. The challenge is about the mixed layer depth. As we know, the mixed layer depth, the left is observation, but the right from models is a lot of difference. So this is the mixed layer. And in this area, we are suffer from the typhoon, the tropical cyclone, so-called. During the past several decades, the for the track of the typhoon is more and more accurate, but for the intensity, no any progress for several decades already. And for the climate, as we know, this is for most of the advanced model. All the models take an average. This is a multi-model mean. And in some areas, 3 degrees higher, and in some areas, it's 3 degrees lower. As we know, so 1 degree sea surface temperature normally will cause a lot of difference. The climate model is so much bias. So this is a challenge we face. So how to improve this is we have, I think we have two parts. One is we look for mixing the ocean, and the other is ice interaction. Ice interaction, just as Juneng mentioned, ice interaction is very important. So my colleagues later will introduce the ice interaction. So here I will introduce the breaking, the mixing. The mixing, previously we did not consider the wave, but the surface wave plays so important role in the ocean and the climate system. And for the icy heat, for icy flux, here and just take an example for before we believe the wind, the direction of wind is the same with the direction of wind stress. However, from observation, it's different. Okay, sometimes it's even opposite. So my colleague later follow my presentation, they were introducing later. Why? This is because of surface wave. Okay, and the second is how to improve. First, we including the surface wave into our model, and this one we can say by including the waves, the mixed layer, the simulated mixed layer is very similar to the observation, so it's dramatically improved. And based on this understanding, we developed the ocean forecast system, as Fred mentioned. So it's our joint work with Farder, Fred, and Samgay, a lot of scientists in this area. And this scheme is also adopted by different research groups from US, from Germany, from so many countries. And the last is for the typhoon and climate. Here I will show you. For the typhoon case, before it's the area is quite large, especially for the super typhoon. Super typhoon, the simulated, the forecast is 2 weeks, but by including the wave breaking into the sea spray, and the intensity will be much improved. So this is for typhoon case. And the next is for the climate model. The climate model, we include the surface wave. This should be the first in the world climate model. By including this, the sea surface temperature bias is dramatically reduced. And in fact, just in this month, there is a new publication from US and they on TRL. So they estimate all the validate all the climate models, and our model is at the top on the simulation of the ENSO. So this scheme is also applied by GFDL. So the summary is we also have host ODC center, and this ODC center have capacity buildings during past 10 years. We have 10 training courses. My conclusion is the small scale surface will play dominant role in ocean turbulence and ice interaction. And with above scientific understanding, we can dramatically improve the predictability of ocean, tropical cyclone, and climate. So my proposal is seamless ocean forecast and service system for predicted ocean. So welcome, everybody can join this proposal. Thank you so much.
Thank you, Professor Fang Li. In the interest of time, please hold your question. We will have a discussion at the very end of the session. So let me invite the second speaker, Dr. Sheng Chen. Dr. Chen is an early career scientist from the First Institute of Oceanography, Ministry of Natural Resources, China. He has been working on the research of AC flux exchange processes. I think he is part of Professor Fang Li Xiao's team. Over to you, Dr. Chen.
Hey, hello. I can hear you. Okay.
Yeah, you have about 10 minutes.
Okay. Good afternoon, ladies and gentlemen. I'm Sheng Chen from China, First Institute of Oceanography. It is a great honor to attend the UN Decade Meeting, Action Incubator 7. Professor Fang Li Qiao has introduced some information of LC interaction. Today, I will introduce our recent work, key roles of surface waves in LC moment flux. I will introduce it from these 4 parts. The first one is the background and aims. We need to know why we study the wind stress. This is a figure that in some LC interaction processes, such as wind stress, C-spree, heat transport, and so on. Momentum flux or wind stress is a key parameter for understanding the physical processes in both atmosphere and ocean. Determination of wind stress is important for coupled atmosphere ocean modeling, weather forecasting, and other application. Ocean surface is mobile in contrast with the rigid land. That is surface waves. So that's why we study the surface waves effect on wind stress. About the surface waves, the total stress is a sum of turbulent stress, the wave-induced stress, and the viscous stress. As Phillips said, the wind and wave interaction is the central question. As the previous studies shown, the wind stress with or considering the wave-induced stress can agree well with the observations. However, there are some many other options. The first one is the modulation of swell on wind stress with height. And the second one is the height that the surface waves influence can reach. The third one is the impact of surface waves at a global scale. So based on this, we give our aims. We use momentum flux and surface waves from a fixed platform to investigate the impact of swell on wind stress. And secondly, we use the wind and wave data from China from satellites to evaluate the effect of surface waves on wind stress from a global scale. Firstly, surface waves impact from a fixed site. We designed a 3-layer flux experiment on a fixed platform. Here is our measurement site. Our observational system was mounted at a height of 10 meters away from the mean sea surface. Near this tower, there is a bottom-supported acoustic wave and current buoy to observe the surface waves. Use this data, we analyzed the test and found the surface wave data state is dominated by swell. So I will study the swell effect on wind stress. Let me show our results. Here, this figure that is a comparison of 3-layer wind stress. We can see they agree well with each other. It indicates that there is a constant momentum flux layer around 10 meters above the sea surface. This is our study's basis. Okay, I will show the 3-dimensional wind velocity spectra. And the wave spectra. We can see that the wind velocity spectra have peaks with the peak wave frequency. It indicates that the surface wave influence can reach a height of 10 meters. Okay, this figure is the turbulence stress and the observations comparison. Without wave-induced stress, from the left to the right is the upper, middle, and lower wind stress. We can see that the turbulence stress is greater than the observations. That's because of swell. And the modulation of swell to wind stress decrease with the height, about 9% for every 10 meters. We also give the wind stress considering wave-induced stress. We can see that this agrees well with the observations. It indicates that the swell-induced stress can correct these deviations. So we have answered the first question. Okay, let me show how high the surface wave effect can reach. This figure is profiles of turbulence stress. We can see that strong swell conditions, the surface wave effect can reach a height of 45 meters. Even in weak swell conditions, we can see that the surface wave effect can reach a height well over 10 meters. And this critical height decrease with the strengthened wind and the weakened swell. Okay, I have answered the second question. Secondly, I will introduce the surface wave effect from a global scale. Global scale, here is C4SAT basic information. We use C4SAT wind and wave data. C4SAT carries two devices, a wind scatterometer SCAT, and the second is surface wave scatterometer SWIM. The SCAT of the wind use 3 days cover the global ocean, cover the globe, but the SWIM of the waves use 13 days to cover global ocean. So firstly, we need to match the wind and the wave cell. Here is the wave and the wind track data points. We based on the time and latitude and longitude to match the wind and wave cell. We can see that the match of wind data points have a successful match with the wave cell. Secondly, we need to grade the data. Why we grade the data? Because there are 13 days wind pattern, some instinct. So we grade the data. We grade the data using 3 degrees multiply 3 degrees. We give the monthly mean wind speed from C4SAT. We also give the comparison with the EIA5. We can see the global pattern or some regional patterns are similar to each other. So we give the surface wave induced stress. It can be calculated from this formula. Only one coefficient is needed to be determined. We use the offshore platform datasets to determine this coefficient. We give the monthly mean wave induced stress for August to November. We can see that the surface wave induced stress is changing with the time. These all are influenced by the wind and the wave field. The last thing is the surface wind stress. We firstly give the percentage of increase or decrease in wind stress after considering the wave induced stress. We can see that from the zonal variations, we can see that at some higher wind speed region, the wind C can increase the wind speed by more than 30%. However, at lower wind speed, the swell can reduce the wind stress. We also give the comparison with the EIA5. We can see that the global pattern is similar to each other. And we also give the meridional mean wind stress. We can see their correlation is very significant. So we answered the third question. Okay, here is our conclusions. We answered the 3 questions from based on offshore platform and China from satellite. Fixed site, we can swell can reduce the wind stress. Swell induced stress can correct the deviation. And the height that swell can influence the wind stress is far higher than 10 meters. Global scale, we use C4SAT datasets realize the inversion of the surface wave induced stress and then the total wind stress. From these all, we can conclude that the surface waves have a key important role in wind stress or moment of flux. Okay, that's all. Thank you.
Thank you, Dr. Chen. A very interesting talk. Please, participant, hold your question. We will have a Q&A session at the very end of this session. So let me now invite Professor Dr. Boyoung-Ju Choi. Professor Choi is a full professor of physical oceanography from Jeonnam National University, Korea. His research focuses on ocean currents and circulation, ocean modeling, and data assimilation. The floor is yours, Professor Choi. So you have about 10 minutes. We cannot hear you, Professor Choi.
Sorry about that.
Yeah, please proceed.
Okay. My title is High Resolution Regional Ocean Reanalysis in the Yellow Sea, East China Sea, and East Japan Sea area. I am Byung-Ju Choi, physical oceanographer in Department of Oceanography, Jeonnam National University. My colleague is Young-Oh Kim. He is a physical oceanographer too. We have 3 operational numerical modeling system for Yellow East China Sea, first one. The second one is East Japan Sea. The third one is East Asian and Asian Marginal Sea 1. So my outline of the talk is I will introduce our activity in Japan East Sea reanalysis and also Yellow East China Sea reanalysis. The lastly, East Asian Marginal Sea reanalysis activity from 2001 to 2010 or 1993 to 2002. The first regional ocean modeling system is East Japan Sea models. It has been operational since 2018 at Korea Hydrographic Oceanic Agency. It's based on regional ocean modeling system ROMS. Horizontal grid spacing is 3 kilometers. It has 41 sigma layers. It also includes river discharge and tide in it. We assimilate temperature and salinity profiles and sea surface temperature and also along track sea surface height using ensemble Kalman filter. We compared reanalysis monthly climatology of sea surface temperature with OSTIA SST data. The upper panels are reanalysis in February, May, August, and November. It's pretty consistent with the observation from OSTIA SST in February, May, August, and November. The RMS error is below 0.9 degrees Celsius. We also verified our surface current using surface geostrophic current from altimeter data. And the upper panels surface current from reanalysis in February, May, August, and November. In November, the path of the nearshore branch along the Japanese coast and the East Korea warm current along the east coast of Korea is consistent with the observation and the reanalysis, and the meandering pattern is also consistent. And however, in February and May, the reanalysis East Korea warm current separate earlier than the observation data set. So we are still working on it to improve it. We also verified our product with the in situ CTD observation data. The middle panel is observed CTD data in February, April, August, and October. The upper panels are from the reanalysis at 10 meter depth temperature. At 10 meter depth temperature, the RMS error is about 1 degrees Celsius to 2.6 degrees Celsius. The problem happens in August. Somehow the reanalysis of cold bias in August, and otherwise it's below 2 degrees Celsius. The RMS error is 2 degrees Celsius. Even in the 100 meter too. We also compared the 10 meter depth salinity data from the reanalysis and observation data. It's a monthly climatology, and those errors are smaller as 0.1 PSU, but in August, still here, we have those problems. The problem comes from the thermocline layers lifted up to the west. That happens, the cold water and cold and salty water moved up in the reanalysis data. Otherwise, it's pretty satisfactory. We also compared our reanalysis product in terms of mean circulation at 800 meter depths, and this is cyclonic circulation here at 800 along the bottom topography. The observation data from the surface ago flood also shows those patterns. However, the speed is a little bit faster in the reanalysis data. And also we have consistent cyclonic circulation at 2000 meter depths compared with the observation. Yellow and East China Sea domain has been operational since 2018. It also based on RAM's 3 kilometer horizontal resolution. It assimilates temperature and salinity profiles and OCR SST data too. These profiles are pretty helpful to have a good reanalysis data in Korea. And also we compare the analysis data with OCR SST data and 10 meter depth CTD observation data. We have generally have a 0.7 degrees Celsius to 1.4, 1.2 degrees Celsius RMS error between two data sets, but we still have some large bias in August, same as the East Japan Sea reanalysis data set. We also compared the vertical profiles and sections along here, 36 degree sections from west to east. When you compare these two data sets, the RMS error was about 1.7, 1.7 something, but it was pretty warm biased in August because of the lower layer is pretty warmer than here, warmer than the observation data here. This is a bias panel here, pretty warm in the lower layer. The last system is stationary marginal system. We call it OPAM here. It's based on MAM5. Horizontal grid space is 4.6, and it has been operational since 2017. We are now working on the reanalysis. We assimilate SST, SSH, temperature and salinity profile using ensemble optimal interpolation method. Especially we assimilate sea surface height data using Cooper and Hines method. It moves vertically, temperature and salinity profile depends on sea surface height anomaly here. We compared the sea surface height patterns in terms of correlation coefficient, and also we compared the sea surface temperature data with respect to the EN4 data set, and we find that we have some cold bias in the East Japan Sea area here. And we also compared the 300 meter depth heat content and the salinity also. And what we found was this OPAM reanalysis data has a fresh bias in the Yellow Sea area. So we have produced Yellow East China Sea and East Japan Sea reanalysis data from 2001 to 2010, and also we have reanalysis data for the East Asian Marginal Sea 1993 to 2002. So by the end of next year, we are going to extend our reanalysis to the 2020, and we are working on the intercomparison with other ocean reanalysis products right now, and we are investigating changes in marginal sea area. We spent most of our research effort on the ocean data assimilation method to assimilate ocean current and surface geospheric current. Thank you for your attention.
Thank you, Professor Choi, for your great talk. We have been allocated, I think, about 5 minutes for Q&A. So I open the floor for maybe, I hope 2 or 3 questions. Any question to our speakers?
So Fred, maybe I can start.
Yeah, sure.
Yeah. Yongju, I just noticed you have the reanalysis of the product is very good. But I have one suggestion is from your presentation I noticed your subsurface you are too cold. They are the bias, for example, at 100 meters.
Yes.
So if you consider the wave mixing, I'm sure it will be dramatically improved. Okay, so you can improve your production quality.
Okay. So I will try to read your research and those things and try to implement those wind mixing into our system.
Okay, we can keep in touch. Okay.
Yeah, that was a suggestion, not a question. Maybe one question. No, if not, I have a question for you, Professor Fang Li.
Sure, please.
Okay, every time I heard your talk is about wave mixing effect, PV. In fact, the first time I heard this, I think more than 12, 13 years or 15 years ago when you gave a talk in Sabah in Malaysia, in Borneo. And that was a point of our friendship actually. And I visited your institute many times and worked together on the ocean forecasting system. So it's been a long time. Progress has been made on this. How do you incorporate wave mixing effects in the ocean model in a couple models? My question is, how successful are we in getting this in CMIP 5, even CMIP 6 model? How many model, in CMIP 6, you have about maybe 50, 60 model. So are they using this, wave mixing effect or only a few model using this?
I'm sure we are the only one to use this scheme in the CMIP 6. That's why the evaluation results of all climate models, we are at the top. So this is very important. As you know, Fred, this is not only the wave-induced mixing, but also the wave play a key role in the IOC interaction. So IOC interaction is also very important. I also, I noticed from the presentation of Juneng, there's some bias, cold bias. Okay, this is for all regional climate models. Sometimes even by including the wave, the sea surface temperature will increase, not decrease. This is amazing. This is in climate system. Thank you.
Okay, that's interesting, Professor Fang Li, because when we run our regional climate model, it is only a atmosphere only. So it's forced by SST, and the SST coming from the GCM. So if perhaps GCM is not incorporating your wave effect, there could be biases in the SST when we take that into our regional climate model. This is perhaps we see biases in the responses in the atmosphere, in the rainfall and so on. So I don't know how to improve this. Perhaps the GCM need to incorporate your BB effect. That's one thing. The other thing, we could also run regional couple model. Okay. But regional couple model is very expensive.
Sure. Yeah. But we can start from you can check our sea surface temperature first. If this is also low or is much better. So
yes. In fact, we soon will be downscaling CMIP 6. So we will look for your model.
Sure. Thank you.
Thank you. And that's the end of this second subsession. So I think I will hand it over to the third session chaired by Dr. Z. Over to you, Dr. Z. Thank you, all speakers. Dr. Z, are you there?
波涛，
哎 ，OK，
现在该你主持了 ，OK。
OK， thank you， OK， let me invite the first speaker of this session, Professor Fazil. Professor Fazil is the director of the Institute of Oceanography and Environment, University, Malaysia, Tangerine. His research focused on the dynamic of ocean coast of Malaysian Peninsula. The title of this part is Protect Ocean from the Scratch. So, Professor Fazil, please share your screen and
all right,
and the reporter.
Can you see my screen?
Yeah, okay.
I just need to check. I'm moving to the next one. All right, can you see it? Because last time I'm presenting, my screen doesn't move. So, all right, thank you very much, Dr. G. Thank you very much to the organizer for inviting me, especially Professor Fang Li. Actually, hello?
Okay,
yeah,
okay.
Please go ahead.
Okay,
no
all right.
problem.
Yeah.
Okay. So, actually, we are late in the afternoon. My presentation will not be a pure science, but it is, we say, a science story, which I believe that our experience on developing the ocean forecast system for Malaysia in this case is quite valuable. I think in some ways we should share some of this experience, because there's lots of other countries now trying to involve in this kind of scientific endeavor. I would say that 10 years ago, Professor Fang Li, Prof. Fredolin Tanggang, and also Song Kiat invited me. At that time, I was really new and just freshly graduated from my PhD. I know nothing about forecast system, but 10 years on, I think those are valuable experience that I think we should engage in, because it involves collaboration, partnership, increase of capacity building, human resource capacity development, and transfer knowledge. So it is basically the gist of ocean decades that we are trying to share. So what I'm going to share with you today is basically something that some important points that we've gone through for the past 10 years until we've managed to develop our own forecast system, and also some of the challenges and opportunity. I share you this image of the report from the IOC Global Ocean Scientific Reports on the ocean we need for the future we want. I think this is the big question that we should ask ourselves as a scientist, on how we're going to make this forecast system very relevant to the needs of our nation. This is one of the images that particularly quite stand out from those reports, showing you a distorted image of countries based on scientific publication in oceanography. So the more you publish, the bigger you get. So you can see that at equatorial or at a tropical area, the country is very small, which indicates that a tropical area region has a very limited amounts of understanding on the ocean. But I think ocean forecast system is one of the that we are developing in our region, especially in the Southeast Asia, has somehow increased our understanding on the region and provide us with new tools to understand better of the future of our ocean. And of course, it's not a short process. It involves lengthy engagement. Started at a regional level with various countries from China, Thailand, Indonesia, Vietnam, Malaysia. So it is a regional level commitment. So it involves training, knowledge transfer, and many more. So this cooperation started with a spirit of developing a forecast system, and it continues because it involved not only developing those models, but also it involved data collection, validation processes, funding. You need money for this kind of research, and so on. So developing your capacity in terms of HPC, computing resources, and so on. So this is all the basically what involved during those 10 years experience. I wanted to just point out just 5 major points, major lessons. I think that we hopefully this might be some guiding principle for any countries that really wanted to take on this journey. I think number one is learning curve. So this is a process of learning. At that particular time, we start with a very minimal knowledge of our ocean. So when we connect with our partners, especially from China and Thailand, I think we develop our capacity building in terms of, if you look at here, I just share you some of the images of our deployment of buoy and ADCP in the sea. Again, even though forecast system is involving more into a computing and programming of the forecasting models, but data which come from the ocean is one of the vital in this case. So it also involves capacity building in terms of training of our staff, our science officer, our crew in terms of deployment and getting data. So this kind of knowledge transfer is very important. And when you have a collective and common goals with your partners, I think this makes our process much smoother. And second one is building the support system. So we need to make sure that we have a strong support system to make sure that the forecast system will be sustainable in the long run. So we need to have our proper computing facilities, and also make sure that your database is there that can manage all the data that you get from the ocean. And then of course see how it works. So in our case, I think we are quite fortunate. I remember that in 2013, Somcat did call me one morning asking me to look at the forecast system because there's a big wave. And yes, 3 days later we got a big wave coming in into our sea, our coast in Terengganu. Same like in 2019, we got Typhoon Pabu, and we captured those typhoon from the buoy data, and our forecast system works very well. Of course, and then translate the vision. So it is not only about providing the best forecast. If you can have the perfect forecast, it will means nothing if we cannot translate it into a much better version so that other people can use it. So this is the spirit of Ocean Decades, to make sure that your output can be used by important sectors like industries and also communities. So in the end, so this is we make it happen. We try to make it as good as it looks. So visualization is a very important tool to make sure that you engage other people's not only oceanographers but also people from different kind of fields, so that they can use this kind of information. Again, if you listen to this afternoon opening, the words co-design, keep repeating, which means that everything that you do, we need to make sure that it involves our partners, so we don't want anyone to left behind this work. So just to recap the overall challenges, and in fact this is an opportunity for others who are now developing their own forecast system. I think it is the only way that we can improve is by making sure that this kind of information and data are being used by other sectors, industries and communities, and government sectors, policymakers. So this data that we get from forecast and also I think observation is very important for future, especially understanding the there's lots of changing in climate. Extreme events require more attention. So if we can incorporate all of this information, it will be a much better output for the use of the nation. And of course, in this case, there's lots of various applications. Fishery industries might need this kind of information. Tourism, maritime industry, I think even some of those have been touched by some of previous speakers this afternoon. And just the last slide, I just wanted to share you because we tried to previously when Fang Li organized a session of a predicted ocean. I was thinking that what is the best way, different kind of ways to share this kind of information, because we have lots of webinars in terms of scientific sharings, but we are yet to have a proper webinars where we can engage with people outside the scientific community. So we organized in last September during the session, we organized a session where we call Engaging Public with Ocean Forecast System. So it is a hands-on training. It's not a training, it's actually a sharing session with offshore industry, environmental enthusiasts, recreational students and explorers. So we gather about 120 participants from 5 countries, sharing them on how to use the forecast system. It is a very interesting session, and I hope that we can find a much alternative and creative ways on engaging other people's to use our forecast system. So I think that's all from me. Thank you very much.
Thank you, Professor Fidel. A great, wonderful report and the challenge and the opportunity for the UN decade of the ocean science. Any question to our speakers?
So maybe after the second, after the second we have discussion. Okay.
Okay. So next speaker. Let me introduce Dr. Sigmari. It's from the Punky Marine Biology Center. And he got his PhD degree from Florida State University. His major and research area are the coastal and shelf dynamic. And Dr. Sigmari, please take your presentation.
Can you hear me? And can you see my presentation?
Yes, really? Yes, it's okay.
Thank you very much for introducing me. I think it's, I would say, good evening, everyone. Now, is it an honor for me to be invited to give a talk today on the topic of toward practical implementation of ocean forecasting system and recent application in Thailand? My name is Chaudhary from the Department of Marine and Coastal Resources, Thailand. It's not okay. First, let me introduce about the ocean forecasting system for the Kingdom of Thailand. This one, I would like to show the chronology of the system. Started in 2012 with the collaboration between Thailand and China. And then in 2015, ocean forecasting system for the Kingdom of Thailand was installed at the Phuket Marine Biological Center. And since then, it has operated till now. For the system, it's a coupled wave model. It's a coupled wave current model system, which obtain the atmospheric forcing from the GFS and give a forecast of wave, wind current, temperature, and sea level.
Sorry. So your PowerPoint file doesn't go forward. Yeah.
Okay.
Stop at the first page. Yeah. Okay.
Can you see it?
Yeah.
Okay. This is just some specification of the ocean forecasting system for the Kingdom of Thailand. And then you can see the product of the ocean forecasting system is wind, current, wave, sea level, and water temperature. But from the OFS to the users. Toward the user, I classify the user of the OFS into 3 groups of people. The first one is those who use the result to support their career. The second one is they use it to serve the specific missions. And the third one is to support a study that can be related to the design of the policy in the future. This kind of just some idea about the user of the data. For the everyday implementation, one can obtain the result. I mean, this one is related to the first group of people. They use it for the career support. And then interpretation of the result is quite straightforward because it's related to their background or experience. So for example, like for the fishery, for the tourism business, or for the transportation, just by looking at the result through the website, they can see that if the wave is about 3 meters high, they can justify if it's it's safe or not safe for them to go ahead for the sea. But the second group of the people, interpretation is not quite straightforward. They need more complicated interpretation as is what you to serve specific mission. As mostly, this is quite important thing because most of the mission that require the result from the OFS as the operational system is they involve with the saving life. For example, like a search and rescue program or mission to limit the impact or for the impact assessment. For example, like some kind of confining the leak oil spill or to reducing the cost of restoration. This, for example, like managing the risk of coral bleaching, or the same is for the oil spill problem. This kind of important because that it's not straightforward and it need interpretation that's based on the required better understanding or related background to the circumstances. This just some examples.
And your slider just on the second one doesn't move.
It moves or not?
No. Yeah. No, it moved to the fourth. Yeah.
This move?
This is to the fourth slider. Yeah.
Okay. So you saw this slide already, right? Okay. This just some.
Sorry. I think you are too secure. So you only share among the second first one, but the second one is move.
You see this one everyday implementation on the topic.
Yeah, we only see maybe the first security.
Can you make it in the presentation mode? I don't know what I see is not in the presentation mode.
This one. Let me share it again. I think. Can you see it now?
It's still not operation mode. Not operation mode.
Model.
Can you see it's in presentation mode?
ป้อมคลิกเป็น full screen นะเพราะอันนี้มันอยู่ในธรรมดาใน PPT ไงคลิกข้างล่างเป็น presentation นะ
คลิกแล้วครับผมคลิกแล้ว
ของป้อมขึ้นแล้วเหรอ บนจอ
ขึ้น
ไม่
แล้ว
ขึ้
คน รับของผมขึ้นแล้วครับ
Oh, she have the problem. He put the moon presentation mode already, but on our screen we could not see it. We still see the same.
Yeah. Doesn't matter. Go ahead.
Yeah.
Yeah.
Yes,
It
okay.
works. It works. Yeah.
Okay.
Very good.
Okay, let me start. Let me repeat this slide. This one is for the second group of people. The thing is quite the difficulty for this group of people is that the interpretation is not very straightforward and mostly require better understanding related to the constant circumstances. For example, like disaster mitigation, and mostly is often involved with the saving life, like a search and rescue mission, limiting impact like oil spill problem, or even reducing the cost of restoration. For example, like to manage the risk due to the coral bleaching. This one, the thing is that time is important to handle the situation in this case. This is some example of the application in the DMCR. We use it to serve kind of specific mission. For example, like the upper left one. This one is during the ship accident in the Phuket Island on the July 5th, 2018. But for this picture, we got a great help from the First Institute of Oceanography in order to support us for the prediction of the finding the body and the people that float on the sea during after the incident. The second one on the red box, is happened in the August this year, because that we got a lost signal from the fishery ship, and then we got informed that they want us to help in predicting the trajectory of the body if it's got an accident. But fortunately, it's for alarm because that the lost signal is due to some kind of problem with the radio, and then they get the signal back in quite many hours later. The second application is to use it for the impact assessment. During the Sri Lanka ship incident, you know that is quite a big, very big incident, and then to prepare for the worst case scenario, we do some kind of predicting if there is a leak of the plastic pellet from the Sri Lanka toward the Andaman Sea. It's better not to have that one, but to prepare for the worst case scenario, we need some kind of information. For the one on the upper right is to help predict the threat or the risk on the coral reef due to the warming temperature, because you know that temperature is the main trigger for the coral bleaching. And then to get to the idea if, where, and when, I mean the development of the situation, that can help in manage the risk. And the one that we can manage, despite the fact that temperature, I mean water temperature, we cannot do anything with that. The third group of people, I mean this one is not done now, but when we have the old phase operated, then we correct the simulation every day. With the several years of the old phase result in the archive, it can be used to study. It can be used for study that related to the design of the policy. For example, like based on the several case of fatality of the marine animal, tracking back to identify the area or locate the area there where they get accident or fatality. With many cases, we can identify which area, where we should pay attention more, and then we can help to have the policy going on. Then, based on our experience, what's the missing part in the implementation? First of all, I already mentioned that for the second group of people, time is very important. But the result from the old phase is actually is the physical variable of the ocean, then how can we make it in the form that is serve specific purpose, like a coral bleaching, like a rescue program? That's one of the most important thing, that to shortcut the time to make the result from the OFS to the application in very short time to serve the purpose, like saving life. For example, like to have the web-based application, which is, I think, is going on in the FIO now, and also provide the pre-analysis of the specific event like a coral bleaching, because we can make use of some criteria or in the index in order to point out if coral is already at risk due to the warming temperature or not. This for specific purpose. And then another way to make it better, make it easier for the implementation is to prepare the data in a proper format for online or offline application that serve some kind of purpose. Like a oil spill distribution, or to create the tool, decision-making tool. But to step forward, obviously, the better result gives the better application. The more accurate application. For this one, one of the gap in the oil field system is that to get close to the shore, you still have some gap area. In that case, high resolution model is still needed. The online application provided to deal with many kind of expected problems that somehow can be of use in the future if we know what kind of application that we're going to point out exactly, and then we can deliver the message that serve the purpose directly. And then the training in the multidisciplinary knowledge in order to translate from the physical variable that got from the OFS into the message that serving specific purpose, that can be very helpful for the people as they can use it and interpret it directly. Thank you very much. That's all my talk.
Thank you. Any question to our speaker?
I have comments for Charlie Murat. Yes, I'm so glad from your report that you already used the ocean forecast system to oil spill and also coral bleaching and or other search and rescue. So many cases. It's very useful. I totally agree with you. Yes, we need a very high resolution. Higher resolution is needed. We can work together for a higher resolution model. Thank you.
Yes, thank you very much, Professor.
I have a question.
Yeah.
For Professor Fazil,
Yep.
you mentioned you have an observation network around your areas. That's very important to improve your ocean prediction scale. What kinds of ocean observation platform do you have, and how do you use those observed data for your ocean forecasting system?
So basically, we have three mooring, two buoy system, man ocean buoy along the east coast of Peninsular Malaysia, and then we have two mooring ADCP also in the east coast, and then we have a regular scientific cruise. So we have like 4 or 5 transect maybe twice every year, sometimes once every year or twice every year, depends on weather and the plan. So that is most of the data that we use. So usually we just use this data set to do some direct comparison with field data. At the same time, field data with the forecast system. So I think for the time being, we can see that it's still quite very good. But now we just improvise. I think we work on the wave model. we just had chance to extract some of our ADCP data to look at to do some validation. So yeah, I think that's so far that's what we managed to do.
Thank you.
Thank you. Professor Fang.
So if no more questions for this part 3, how about we move to the last, the part 4, discussion and the possible cooperation. So any suggestions, comments are highly welcomed. We still have about 10 minutes, but don't mind. If we need more time, it's also okay. Please go ahead. Any questions, comments?
Professor Fang, can I start?
Yeah, sure, please.
Yeah. Okay. My earlier comment about your BB effect. When I asked a question, I was a bit disappointed with the answer, which is you said that most likely that your model is the only one that in CMIP 6 or CMIP 5 that using this BB effect. That is not much of a progress in terms of convincing the world that the wave mixing effect is important. But my concern is how to improve the regional climate simulation. And to convince people that there is an improvement. There is an improvement when come to using the couple model from the GCM incorporating the BB effect as opposed to those without BB effect. So my preposition here, perhaps if you like, within the Codex Southeast Asia, which I'm actually leading, we can conduct an experiment to test whether your model, can better simulate, when we downscale with our regional climate model, can be better simulating the atmospheric variable, rainfall, temperature, and wind, and so on. And we can design the experiment together. Maybe, I don't know, maybe you have a run that do not have wave effect. We can downscale that as well and compare. And I think if we can show that BB effect can improve the regional climate simulation, perhaps that's one way to convey this as well. It's just a suggestion from me.
Okay, thank you very much. So I have 2 points. The first is, in fact, more and more groups, research groups, apply as the BV, but it's not easy for the for CMIP. As we know, CMIP is for run the model for so long time, is for several thousand years. So yes, so most groups think, okay, it's maybe a high burden for the high cost for computer. In fact, it's not so much. As we know, the computer is more and more powerful. Now in Europe, the most the use of the model is NEMO, and in the NEMO model, they also incorporate this BV into their as a function. And in GFDL, as we know, GFDL of the United States, they play a leading role in model development, and they also test. By including the BV, they can dramatically improve their climate model. So the world now, more and more people already noticed. So the wave is really important for climate, for the global ocean circulation. So I think that we have good start. The second is, I totally agree with you, is we should start to test the regional climate model with and without this wave effect. What's the difference? As we know, the regional climate model can provide a very high resolution result and for the users, and if we show the results clearly, the effect of the wave, I think more and more people will use this game. Okay, thank you so much. We can start here. So any other question, comments?
Professor Bang.
Okay, yeah, some case is
thank you very much, Professor Fang Li.
Samge, you are muted. Samge.
Okay. Sorry. Okay. Thank you very much, Professor Fang Li. I think today is very important for us because many of the experts, or the people who are the user of those kind of the ocean forecasting system to be benefit to the people. I think if before the end of this this session, if all of you try to come up with something, we can move forward in the near future to develop this kind of cooperation to make it to be, strong, something like strong action, we can develop at the project as Professor Fang Li already mentioned in the early that we can make develop something like the project for the UN decade and work together for next 10 years. I think today maybe discussion we try to talk less about the scientific. If we stop develop together in the next 10 years, we have more time to talk about it. But today we have very little time. If you have some kind of suggestion or direction, we can move together. It will be good, right? That is just for my comment here.
Thank you so much, Samge. I think we, through this incubator, we hope to find more, cooperator. We work together to propose a program to the UN Ocean Decade for the ocean forecast system. Thank you so much. So further, please.
Yeah, I just want to echo what Samke is saying. Maybe you can, I just want to hear your thoughts on, so we're talking about ocean decades. Is there any, are you planning any specific improvisation on the, one is on the forecasting system itself? Because I believe that, I think for instance, that when we do our Malaysia forecast system, I think we're trying last time to maybe in the future, trying to look at if we can add in river discharge into the system and then improvise some other things. But I'm not sure whether it's should be discussed or maybe you have already have some plan within the group what's going to happen in the next few years, to improvise the whole system. And also number two, I happen to also come around to, there is one also group, they call it a coast predict, which is some sort of similar to, but I believe that it might be a slightly long-term kind of work. So we are more forecasting like 4 or 5 days. But yeah, I think again, the direction of what we are doing is actually to look at improve how we can direct this output into the right industry or how it can impact the nation of certain countries. Yeah, I think that's some of the point that maybe we can explore more in the future.
Great. I totally agree with you. It's the first is we, as we know, there is also a program is a coastal project, but our program, our proposal will be not only focus on ocean forecast, but also to climate. That's why our title is from ocean to climate. So we hope you of course you are a key partner for this proposal. And we also need many partners from end users. The end users. So today, Professor Guotao Xie is an example. They from the oil offshore oil company. So they propose us. They showed us clearly. So what they need, okay, from our ocean forecast system. I think that's a very good start. And I'm quite, confident we can from here, we can have a very good proposal. Thank you very much. Professor Choi.
Yes, thank you. It was a great meeting. I understand there's so many systems in Asian areas. It was good to know. And one thing I wanted to inform you is ocean prediction system and data simulation. Those there are some international collaboration under the Ocean Predict. Ocean Predict is formerly it was known as GODE Ocean View. Yes. I attended this meeting for 10 years and I learned a lot of things. I didn't know anything about data simulation and ocean prediction system, but they provide a lot of information how to build a system, how to maintain them, how to apply them. So this one of the task team I would like to recommend you to, or I would like to invite you is COSTT. COSTT is a task team representing coastal, ocean, and shelf sea task team. So keep eye on those activity of those teams, and they are recruiting the national representative from every nations, and they would like to diversify their pools. Mostly the Europeans are attending those groups. So, and I have a suggestion. That was my recommended suggestion is I would like to have some groups for the ocean forecasting system for this area, Asian Sea areas. Probably the China and Malaysia and Thailand might have some collaboration, but I would like to join with your groups, and also would like to form a international collaboration for us, and we can form a group for the prediction system and data simulation, like one. The second one is, as Professor Fang-Li Chao mentioned, about surface mixing by wave and wind and parameterization, those groups. And third one is like we would like to have a regional climate change issues. So not a global one. We can have our own regional climate change one. So we can have a reanalysis data and future projection for the regional areas. And we can have those regional climate projection or prediction groups might be one I would like to form through this incubator.
Thank you so much, Yongjin. First of all is for the ocean project. In fact, I keep a very close eye on this ocean project, and I also discussed with the co-chair. Co-chair is Eric. Eric is my friend also. It's and he also asked me to to join more activities for the ocean project. I think we no problem. The second is, of course, you are highly welcome to join the cooperation. No any problem. It's quite open. Okay, and the third one is for the regional climate. So that's why this time I invite Professor Tan Gang to join us. As he introduced, in fact, we are very close friends. It's a long time ago. But at the beginning, we cooperated on the ocean forecast system. But later on, he moved to the climate, regional climate. So that's why after that, he is also very busy and and leave the ocean forecast. But recently, we think we should restart because regional climate is also very important, and we should cover this area. So no problem. All these your suggestions, excellent. Thank you so much.
Can I make a comment, Professor Fang-Li?
Sure, please.
Yeah, since regional climate projection was mentioned by Professor Choi, this is actually the key area of CORDEX. I don't know whether you know CORDEX or not, but CORDEX is a program under WCRP. And throughout the world, we have 14 domains. In Asia, we have one East Asia domain. In Asia, we have three or four domains, including East Asia, Southeast Asia, and South Asia. And of course, the main issue there is to project, to downscale the GCM to a higher resolution, so that the climate is better simulated. The product is higher resolution, so that impact impact assessment can use this for doing the impact assessment on the impact of climate change. But the challenge that we have in Southeast Asia, for example, as shown by Dr. Joning earlier, that we have biases. So the challenge for us is to reduce those biases. And those biases, of course, contributed by not only the model that we use, but the GCM themselves. You know? So the biases, this model, is forced by the GCM at the boundary, at the lower boundary, at the surface, forced by SST. Mm-hmm. So if the SST basically is, a contained error bias, mm-hmm. you don't expect it to be producing, correct climate. So this is why I'm keen to test your model, Professor Fang Li, mm-hmm. Whether the BB effect can reduce this bias. So if we can do an experiment simulation with, in the GCM simulation with BB effect and another same model but no BB effect, we can run our model, nest our model within your model, and downscale this, and we see the effect on the regional, whether the bias is can be reduced or not. So that's one way, of course. But the other option, we can run couple model. Mm-hmm. In the couple model in the ocean, regional ocean, perhaps we can introduce BB model. But as I said, couple model is expensive. Most of people involved in Codex, smaller group, mm-hmm. with limited computational power. But I think it is a good suggestion by Professor Choi. I'm more excited to get more people involved in this, in looking at perhaps what are the ocean processes in the regional scale that important for for us to capture this regional climate correct. Mm-hmm. So of course the AS interaction is quite important.
Thank you so much for your comments. I think we have so many common interests. So next is Azam, please.
Thank you, Professor Chiao. I want to ask one question is that, so we are trying to prepare our model with the ROMS model for ocean forecasting system for future model in Bangladesh. So I want to know which model do you use for your ocean forecasting system? Like in Thailand, I know they are using the POM model, right?
Yeah.
So anybody is using the ROMS?
ROMS, we also have the experience. We also test if for example, for including wave, what's the effect in the ROMS model. We have the experience. Okay. And recently we set up a regional model. Is covers the Indian Ocean, the West Pacific Ocean, and the South China Sea. So this model is the resolution is 1/30 by 1/30. That's about 4 kilometers. And this model is based on ROMS.
Okay, thank you so much. Then we can take help from you, because in future we just preparing our model, and we are just about to get the BB effect in our model. Thereafter, if there is a scope, then we will try for the some case study for the OFS.
Okay, great.
Thank you.
Thank you so much.
Yeah.
So any more questions, suggestions? So if no more, I think today we have a very excellent incubator, and we have have 8 speakers, invited speakers, and I take this opportunity to thank all. First to thank the speakers. So with your high quality speakers, so we received some new knowledge on the ocean forecast system. And I also would like to thank all the participants. I really hope in the near future we can, sit together, okay, face to face, have a discussion, and we really hope to have cooperation. So in fact, today we have very good 2 examples. One is from Father there. Father, as he introduced the story, is 10 years ago. Just with 10 years, so many progress in Malaysia. And the second example is from Thailand. Chaudhary is he showed, so the ocean forecast system is already served the the management, serve the government. So it's very good, simple for us. And we hope this is just a start, not the end. So hope to see you soon. Thank you so much. Thank you.
Thank you, Professor Bang.
Thank you.
Thank you. Bye. Thank you.
That's good.
Bye.
Thank you.
All right. Bye, everyone.
Bye-bye.
Bye.
Bye-bye.